Hi everyone, welcome to another episode of my YouTube channel Data Science with Sam. This vlog is a continuation of the series on unsupervised learning that I started a week back. In my previous vlog, I covered what is the main definition of unsupervised learning, how it differs from supervised learning, and I also covered some of the key aspects of unsupervised learning in our industry practices. So if you missed that video, I'll definitely recommend you to go back to my channel and watch that vlog before we move further with this one. So today I'm going to talk about one of the very important clustering techniques which relates to unsupervised learning. And that is hierarchical clustering. Because hierarchical clustering is very useful when you try to unravel an unlabeled dataset and try to find out the pattern and form different clusters based on the similarity of different data points. So let's check out in the next section how hierarchical clustering will be beneficial for your unsupervised learning work. And do not forget to like and subscribe to my channel because more data science related contents are forthcoming. And if you want to learn more about unsupervised learning, please stay tuned and subscribe to my channel because I'll be covering more contents on clustering techniques, DBScan, and any other aspects of unsupervised learning in next few weeks. So let's go to the next section for hierarchical clustering. So what is hierarchical clustering? As the name suggests, so this is a machine learning technique where you are forming cluster in hierarchical way, such as like you're forming a dendrogram where each tree node of the dendrogram represent one cluster. For this clustering technique, you do not have to specify the number of clusters beforehand. Rather, it will be formed dynamically as you progress through the algorithm. This clustering technique is also more deterministic and it has less iterative refinement. There are two different categories when it comes to building algorithms for hierarchical clustering. The first one is agglomerative, which uses a bottom-up hierarchical approach where you can actually start with a singleton cluster and slowly merge two clusters with similar nature and form a single one. So at the end of the agglomerative algorithms, you form a macro cluster comprised of all the single clusters in the dataset. Whereas there is another approach called divisive, which is totally opposite of agglomerative, because this algorithm takes a top-down approach where you start with a huge macro clusters and split it into subclusters before you end up generating a single cluster for each data point. So does it sound a little confusing? So let's check out this diagram. When it comes to agglomerative algorithms, let's say that we have 5 different steps to form a clusters from a singleton level to a macro level. Okay. So here in the diagram, first, say suppose at the step 1, we have 5 different clusters, A, B, C, D, E. Then in the step 2, what we're doing that we are forming a cluster merging A and B first. Okay. In the next level, in step 3, what we're doing, we are merging D and E together. Okay. So now we have A, B, and D, those two clusters from two singleton. Then the next one is we are forming a cluster between C and DE, which you can see over here, the CDE. So it's like a cluster of these 3 data points. So now we have AB, one cluster, and CD. So what we are doing here, we are basically bring down the cluster number from 5 to 2. Now, what's the final step? In the final step, we are doing that merging of AB and CDE into a macro cluster. So ABCDE is kind of like a macro cluster that we formed using the agglomerative algorithm technique. So now what is divisive? As I mentioned earlier, it's just an opposite of agglomerative approach. So if agglomerative is more of like a bottom up, since you're basically merging all the singles cluster into a macro cluster, then the divisive would be a top down. So here what we're doing, here we basically just splitting ABCD to CDE, and then we are splitting CDE to DE, and then we are splitting DE to D and E cluster. Whereas if you see on the upper section, we are basically splitting the same ABCD to AB, and from AB cluster, we are splitting it into 2 singleton cluster A and B. So it's just the opposite of each other. So that's kind of like give you an overview of how you can work on agglomerative and divisive. Based on your unsupervised learning need, either you can follow an agglomerative approach or divisive. In most of the scenarios, we usually take divisive approach because we have an unlabeled data set of large clusters, but then we have to split them into single clusters to make sure that all the data points with similar nature formed a similar clusters. Now let's check out some of the key methods of agglomerative algorithms. The first is it used different similarity measures to form clusters. It also continuously merged nodes that have the least dissimilarity. And eventually all nodes belong to the same clusters. As is shown in the previous diagram, that A, B, C, D, E, those 5 clusters actually merge into a macro clusters at the end of agglomerative phase. Now, there are 4 different similarity measures that we can apply during agglomerative algorithm building phase. So the first one is single link, where we actually calculate the similarity based on the most similar nearest neighbor members. Like here you can see it's like the most nearest neighbor members are connected using this single link. The next one is the complete link or the diameter. Here we actually calculate the similarity based on the most dissimilar points of the 2 clusters. So here actually we are considering the full diameter, and if we found out that one of the diameters are actually least, so based on the least diameter, we form these 2 clusters into one. The next one is average link, where what we do, we usually calculate the average distance between each data point of each clusters. It's very expensive to compute because you have to basically calculate the distance of each point of these 2 clusters and then calculate the average, whichever the points actually have least average distance. So based on that, you form those 2 data points into one clusters. So it takes time to use this average link approach to form 2 clusters. And the final one is the centroid. Here we just use the centroid of 2 clusters, and based on that we merge them together. Now let's check out in the next section what are the key methods of divisive algorithms. For divisive algorithm, we use top-down approach. The process starts at the root with all the points as one cluster. Means we are basically considering the macro cluster at the stage 1 of divisive algorithm. Then it recursively splits the higher level clusters to build a dendrogram. Okay, it seems like considering that the big clusters are split into different tree branches, something like that. Then after that, we can consider actually divisive as a global approach. As I said, that in most of the cases, we deal with a big data set and you have to form clusters from that data set. You use divisive approach, because all the data sets are clustered into one single macro region, and you kind of split all the macro region into their similarity and from clusters accordingly. This algorithm is more efficient when compared with agglomerative, but obviously because in divisive we can actually use the top-down approach, which is more essential for performing any unsupervised learning approach in the machine learning world. The next thing is which cluster to split first. Okay, so now there must be some kind of confusion that when you are actually splitting the clusters, at the first stage you have the macro cluster, right? Then after that, when you split the macro cluster into 2 subclusters, now we can get confused that which subclusters we should go first. So in that case, what we do, we usually calculate the sum of squared errors of those 2 clusters. And which one will have the largest sum of squared errors, we'll start with that, because our main approach is to lower the errors. So we want to minimize the errors. So whichever has the largest sum of squared errors, we'll split that cluster first, and then after that we'll go with the other one. Finally, again, please remember that divisive algorithm is nothing but the inverse order of algorithm. So eventually each data point form a cluster of its own. So that's the final stage of divisive algorithm. So now let's go to the conclusion section just to wrap up this vlog. Hope you like this video as it covers some of the important techniques of hierarchical clustering. Whether it's agglomerative or divisive, you can always choose which algorithms will be applicable for your data science work when you deal with unsupervised learning practice. In my next video, I'll talk about some of the coding example of hierarchical clustering. Because now you know that theoretically how you can build your clusters using any of those 2 algorithms. But you need to understand how you can apply that and formulate it in your code. So I'll cover that in my next vlog before I move to the k-means clustering section, because k-means clustering is also a very important aspect of clustering techniques. So check out for my next vlog in order to understand how you can perform a coding exercise using hierarchical clustering. So until then, goodbye. But don't forget to like and subscribe to my channel because there are more contents are forthcoming. Stay safe. Take care.